Hi guys, this is a quick video to show you a little bit of a comparison between the median and the average. A common misconception that people have in general is that the median and the average are the same thing, and they aren't really. They're both attempting to describe where the center of the data would be, but they're doing it in slightly different ways. The median crosses them off until the middle is left, and the average takes into account all the sizes of the numbers in order to find where it thinks the center would be. So I've created this situation where we have 17 people, and I just put a bunch of random numbers in here, and maybe it's the number of vacation days left. Down below you can see that there's this distribution. This is a histogram since my data is quantitative and it can be averaged. So the original list over here is out of order. One of the first things that you need to do if you're going to find the median is put things in order. So I've taken this list, I've copied it over, and then I've just sorted it from small to big. If you don't sort it from small to big, finding the median is not accurate. Now up to the right, you can see I've color-coded some things. These are the different descriptions that you could have about these 17 people. So the first idea here is this 5-number summary. You have the minimum number of vacation days left, you have the maximum number of vacation days left, and then Q1, Q2, Q3 are the 3 different quartiles. Between 0 and 3, a quarter of the population is between those values. Between 3 and 5, that's another 25%. Same thing between 5 and 7, and then 7 and 10. Quartiles split your sample up into quarters. One thing that we discussed in the notes is that the IQR, meaning how far it is from one end of the box to the other, is that's pretty important. So the distance here is 4 because 7 minus 3, Q3 minus Q1. You can see that calculation described under IQR. Now in order to find outliers, you need to take this distance into account. So if you multiply your IQR by 1.5 and then attach that onto either Q3 or subtract it from Q1, that's where you get the boundary for where outliers will start to happen. So you can see 7 plus 6, that distance leads you to 13. Upper outliers will start beyond 13. Since 10 is the most number of vacation days left, I don't have any outliers up there. If I look on the left-hand side, because there can be outliers on the left of a distribution, 3 subtracting 6 produces negative 3, which you have to kind of think there's a natural boundary at 0 vacation days left. They've used all their vacation days. So no outliers on the left and no outliers on the right. This type of description is actually really nice if we have outliers, and I'll show you what I mean here in a second once I compare it to what's in blue. So down below I have the average. Finding the average is as simple as adding them all up and then dividing by how many people there are, in this case 17. So if I took that total, which is 88, and divided by 17, I get an average of 5.176. It's calculated right here. Now what we don't know yet is the standard deviation. Standard deviation describes the spacing or the spread of your data. So larger standard deviations means it's spread out more versus smaller standard deviations, it's more compact. And you can see that here a little bit. The standard deviation being 3 means it's a little spread out. The closer this gets to 0, the closer everything will get to piling up right around the average. Now we're going to talk about the standard deviation, how it's calculated. You can see this arrow off to the side. There are 5 steps to calculating standard deviation. And it's important that you understand the process, even though a lot of times we'll use our calculator or a computer to find it, just because it's time intensive. So the first thing you have to do is you have to take your data, and step 1 says subtract the data from the average to see how far away it is, either above or below. So I have this column of answers. Essentially what I've done is I've taken 6 and I've subtracted the average away from it. 6 minus 5.17 is about 0.8. This is slightly above average. 6 is slightly above 5. Then I did that for 7. 7 minus the average says it's about 2 above. 3 minus the average, 3 minus 5 actually produces negatives. And what this says is it's fairly far below average. So you can see for 6, slightly above average. These are the same two values. 10 above average, and the bigger the number here, the bigger the gap between these two. You can see 0 compared to our average is fairly far below. And so once you've calculated that, just using simple subtraction, we can move on to the second step. Step number 2 says square this distance so that no negative values exist. Now what this is going to do is it's going to give preference or weight to the larger distances. So if I take 0.8 times 0.8, I get this value. 1.8 times 1.8 is about 3.3. And then when I take negatives, negative 2.1 times negative 2.1, slightly over 4, you can see larger distances produce larger answers here in this second column. So going through and squaring all of these values will produce these answers. Some of them are pretty big. If you look at 0 hours, when you found that difference, and then you squared it, it's over 25. So that's a little bit of the weight I was describing in the instructions. After you do all that work, step number 3 says add up all of the values that you just found to find the total squared distance. So if we take those and we sum them, we get 183, which is a little weird that it's a nice whole number. Many times it will not be nice and whole. And that's okay. You just take a couple of decimal places trying to preserve accuracy. Now I have step 3.5. This is something you can do along the way. It's not very hard. You need to ask yourself, how many individual pieces of data do I have? Then you're going to subtract 1 from this. And there's an important reason. This is something I always kind of wondered. Because we're not dealing with everyone, because we're assuming these 17 people are a sample of maybe a larger company or some other group, we have to factor in kind of this potential error. And so even though there are 17 people, if we divide by 16, our error is going to be factored in a little bit. And so the less people you have, the more error you have to account for. The more people you have, the less this really makes a difference, okay? Because these two numbers will get increasingly close to each other in terms of proportion when you do the next step. If you didn't follow that, that's okay. Just take the number of items that you have and subtract 1, and you'll get your answer for this second half of step 3. Moving on to step number 4, we're going to take these two numbers and we're going to divide. And this produces what's called the variance. So 183 divided by 16. If I do that fraction right here, I get 11.43. That's the variance. It talks a little bit about how varied the data is. The larger the variance, the more variation is going on. The smaller the variance, the less variation is going on. Now this whole process is to find the standard deviation, and we haven't found that yet until you take the square root of the variance. So that 11.4, we're going to square root that. And this number is called the standard deviation. Again, it describes the spacing. So similar to how the IQR describes the spacing of the middle 50%, okay, from here to here, that's the middle half of your data, all within 4 of each other. The standard deviation attempts to describe this spacing as well, but it's doing it slightly differently. Obviously, there is a lot more work involved. But when we get to our next chapter and we start dealing with particular types of graphs or distributions, this number is extremely powerful. The IQR, it's easy and fast, but it can't do as much as your standard deviation. A lot of things in statistics depend on the standard deviation and the average, which sometimes we call the mean. So the mean and the standard deviation is important. Now one thing that's really interesting is what happens to these two ideas if I change one piece of information. It's handy because I have a spreadsheet here and we don't have to go through all the calculations again. The computer will do it for us. I'm going to take the 17th person and change the number of days they have left of vacation to something crazy. So this 17th person had 10 days left. A few other people had 10 days as well. But what if they had 25 days, more than 3 weeks worth of vacation? Well, you can see the graph right away separates that person and puts them all the way out here. So many more days of vacation left than most people. Now, did the 5-number summary care about that one person switching? Well, the maximum cares. We have to take that into account. But Q3, Q2, and Q1, those 3 quartiles are actually the same. Because changing one person and making them more extreme typically won't change, or at least it won't change it very much, what your quartiles are. Quartiles really care how many people, and I still have the same number of people, so the middle isn't impacted. Now if I add another person, like an 18th person here, those numbers will change a little bit. Notice the IQR, the spacing, is also still the same. This 17th person would technically be an outlier. They're past the boundary of 13. So my box and whisker plot would have to take that into account and take the whisker out to 10 and not 25. Now if I go ahead and change this back to 10 so you can see the difference, watch what happens to the average and the standard deviation. Here we go. That person becomes an outlier and the average went from being around 5 to being over 6. Changing one person impacted the average by quite a bit, a whole day of vacation. The standard deviation, the spacing also went up because you can see there's just a crazy amount of space in between here from that one person switching. Quartiles and the median don't really care if there are outliers. It didn't impact that much at all. But the average and the standard deviation, the spacing, they care a ton because they take into account that this is 25 days of vacation. Everybody plays a role in the average. This is just how many people are in the list. If I go over to the standard deviation, you can kind of see the difference of this person compared to average. They're 18, almost 19 days above average. When you square that, it is huge. This is really one of the reasons why the standard deviation is thrown off. So adding those all up, you can see it's not a decimal. 17 people subtracting 1, since it's a sample, leaves you with 16. And if you divide those, you get 32. That's our variance. If you square root 32, almost 33, you get 5.73. That's where this number comes from. So the spacing is so much greater. Again, what the median and the average are attempting to do is describe where the center is. Is the center right around 6? Well, I don't know. So the average is a little bit biased towards this one singular person. Is the center more around 5? That's what the median says. Well, I know it's not that much less than 6, but it's a little bit more towards the center of this big chunk. Median, not impacted as much by outliers. The average, definitely impacted by outliers. Just to get that idea across, I have several graphs that I want to look at. Which idea would be better? Would the median be better, the middle, or would the average be better? If you look at this shape, this is fairly symmetrical. It goes up to 3, it goes down to -3. I know it's not perfectly symmetrical, but it's a pretty decent graph. It would be advantageous to use the mean, the average, and then the standard deviation because there aren't any outliers. It's not skewed one way or another. So the average and the standard deviation would be best. Remember, those two things are very powerful. The next graph, you can kind of see the left-hand side stretched out a little bit. Not very symmetrical. This is skewed, probably skewed to the left. And when you skew things, those unusual values start to really impact the average. So you don't want to use it. It's biased. In this case, I would use the median, the middle. So that 5-number summary, the interquartile range, that would tell you where the center is, a little bit better than the average. This graph, I know it's blurry, definitely skewed to the right. Since it's skewed and there are outliers over here, the average is going to be skewed and biased towards those people since they all factor into the average itself. The median, crossing off the middle, so there are less people here, that'll start to represent the center of the graph a little bit better. So I would use the median and the 5-number summary. In this graph, this is symmetrical, not perfectly symmetrical, but you can see it's kind of balanced on both sides. I would use the average and the standard deviation in this case. This graph is skewed to the left. Since it's skewed and there are outliers impacting the average, don't use it. I would use the median and the 5-number summary. This graph is just skewed the opposite direction to the right, so again, use the median and the 5-number summary. Finding the middle represents the center of this graph a little bit better than finding the average, which is pulled towards those outliers. This graph is fairly symmetrical, so the mean, also known as the average, and then that standard deviation, that spacing, that would be more informative. Now, something that we'll talk about is that when it gets closer and closer to being symmetrical, those two ideas tend to get closer and closer to each other. But that's not something I'm going to ask you to know yet. But it is kind of interesting. Almost done with our graphs here. This is fairly symmetrical, and so using the average and the standard deviation is the way to go. Remember, that standard deviation is those 5 steps to find the spacing. The last graph that I found, definitely skewed to the right. So we have outliers way out here. This is not symmetrical. And since those outliers would impact the average, I don't want to use it because that answer would be biased towards those upper values, those extremes. I would probably use the median and the interquartile range and the 5-number summary. All of those things are more dependent on how many pieces of information and not necessarily what values those pieces of information are. Overall, I hope this video helped. Again, this idea of like what happens if you just change one piece of information. It tells you kind of which statistic you would maybe want to pay more attention to. Sometimes companies will use one of those because they're deliberately trying to make you think a certain way. And so you need to be aware of how they behave. That way you can ask questions and think critically. We'll see you guys in the next video. Thanks for watching.